One of the best Volvo factories producing giant diesel truck engines is Volvo's powertrain production facility in Skövde, Sweden. This factory is a crucial part of Volvo Group's global production network, manufacturing high-performance diesel engines for Volvo trucks, Volvo construction equipment, and other heavy-duty applications. Inside Volvo's Skövde Factory 1, advanced manufacturing and automation Skövde facility is highly automated, using cutting-edge robotic systems and AI-driven quality control. It produces both inline-6 and V8 diesel engines for Volvo's heavy-duty trucks, including the D13, D16, and D8 engines. Precision machining ensures engine components meet strict tolerances for reliability and fuel efficiency. 2. Sustainable production factory operates with 100% renewable energy, significantly reducing its carbon footprint. Waste heat from the production process is reused for heating, making it one of the most energy-efficient facilities in the industry. 3. Engine assembly and testing. Each engine undergoes rigorous testing, including cold start simulations, high-load endurance testing, and emissions control calibration. Volvo's Euro 6 compliant engines are built here, ensuring they meet the strictest environmental standards. For innovation and research facility is also a center for engine R&D, where Volvo develops hybrid and hydrogen-based powertrains for future heavy-duty trucks. Engineers work on turbo compounding and fuel-efficient diesel technology to improve power output while reducing emissions. Other key Volvo engine factory Schagerst, Maryland, USA produces diesel engines for Volvo Trucks North America and Mack Trucks. Lyon, France, specializes in mid-range diesel engines and powertrains for Renault Trucks and Volvo. Curitiba, Brazil, supports Volvo's operations in South America with locally manufactured engines. Inside Volvo's Skövde factory, how giant diesel truck engines are made. Volvo's powertrain production facility in Skövde, Sweden, is one of the most advanced factories for manufacturing heavy-duty diesel engines. This plant produces engines for Volvo Trucks, Volvo construction equipment, and Mack Trucks, focusing on efficiency, sustainability, and innovation. 1. Manufacturing process. From raw materials to powerhouse engine. Step 1. Precision machining of engine components. Process begins with raw cast iron and aluminum, which are turned into engine blocks, cylinder heads, and crankshafts. CNC machines, computer numerical control, and robotic arms ensure extreme precision, reducing the need for manual labor. Every component is machined to a tolerance of microns to ensure a perfect fit. Step 2. Assembly of the engine block. Cylinder block. The engine's backbone is fitted with crankshafts, pistons, and connecting rods. The crankshaft is balanced to minimize vibrations, crucial for reliability in long-haul trucks. Cooling and lubrication systems are integrated at this stage to ensure the engine operates efficiently under high stress. Step 3. Turbocharging and fuel injection system installation. Volvo's heavy-duty engines use variable geometry turbochargers (VGT) for optimal performance across different RPMs. Advanced common rail fuel injection systems inject fuel at high pressure up to 2,500 bars, improving combustion efficiency and reducing emissions. Step 4. Emissions control and after-treatment systems. Volvo's selective catalytic reduction (SCR) and exhaust gas recirculation (EGR) systems ensure compliance with Euro 6 and EPA standards. Diesel particulate filters (DPF) and diesel exhaust fluid (DIF) systems help cut NOx and particulate emissions. Step 5. Dyno testing and quality assurance. Every engine undergoes rigorous dyno dynamometer testing, where it runs under extreme conditions to simulate real-world trucking operations. Sensors monitor power output, fuel efficiency, emissions, and thermal performance. Only engines that pass Volvo's zero-defect policy move to the final assembly. 2. Volvo's most powerful diesel truck engines. Volvo D13 13-liter inline-6. Power, 405 to 540 up torque, 2,600 N. Features. Turbo compounding for fuel efficiency. Optimized for long-haul trucks FH and VNL series. Volvo D16 16-liter inline-six power, 550 to 750 up torque, 3,550 Nm features, designed for heavy-haul trucking and construction equipment, offering high torque at low RPM is Volvo D8 and D11 smaller displacement for regional hauling D8, 7.7L, 330 horsepower, mainly used in medium-duty trucks 11L for 125 horsepower, balanced for fuel economy and performance 3. Sustainable and future innovations hybrid and hydrogen-based powertrains. Volvo is developing hydrogen combustion and fuel cell engines to phase out diesel by 2040. The factory in Skövde is already adapting its production lines to accommodate next-generation hybrid electric and alternative fuel engines. Green manufacturing and CO2 reduction. Skövde operates on 100% renewable electricity, reducing carbon footprint significantly. Waste heat from machining is recycled to heat the facility and surrounding community. Advanced oil filtration and reuse systems reduce industrial waste. For other Volvo engine factory, Turbocharger, Maryland, USA, produces diesel engines for Volvo and Mack trucks in North America. Lyon, France, manufactures mid-range truck engines for Renault and Volvo trucks. Curitiba, Brazil, produces Volvo engines for the South American market. Deep dive. Volvo's next-gen hybrid engines and testing procedures. Volvo is leading the transition from diesel to hybrid and alternative fuel engines, focusing on sustainability without compromising performance. Their next-gen hybrid and hydrogen-based powertrains are being developed alongside rigorous engine testing to ensure reliability for long-haul trucking. 1. Volvo's next-gen hybrid and alternative fuel engines. Hybrid electric diesel powertrains. Volvo is integrating electric motors with diesel engines to improve efficiency. Energy recovery systems store braking energy in lithium-ion batteries, reducing fuel consumption by up to 30%. Trucks can run on pure electric mode in urban zones, reducing emissions and noise pollution. Example: Volvo FM and FH electric hybrid models are being tested for long-haul applications. Hydrogen combustion engine. As Volvo is developing hydrogen-powered internal combustion engines H2ICE that operate like diesel engines but emit only water vapor. These engines are optimized for heavy-duty applications where battery electric technology is not yet practical. Hydrogen fuel injection and turbocharging ensure high efficiency and power output. Expected to be deployed in Volvo FH and FM models by 2030. Fuel cell electric trucks. FCEV. Volvo, in collaboration with Daimler, is advancing hydrogen fuel cell trucks. These trucks generate electricity from hydrogen, offering a range of 1,000 kilometers, making them ideal for long-haul trucking. Zero emissions and fast refueling, 10 to 15 minutes, make them a promising diesel alternative. Set for commercial rollout in 2030 to 2040. Biodiesel and HVO, hydrotreated vegetable oil. Volvo's existing diesel engines, such as the D13 and D16, can already run on renewable biofuels. HVO, hydrotreated vegetable oil, is being promoted as a drop-in replacement for diesel, reducing CO2 emissions by 80 to 90%. 2. Volvo's engine testing procedures, ensuring reliability under extreme conditions. Volvo engines undergo rigorous testing before they are installed in trucks. Each engine must withstand millions of miles of simulated and real-world driving conditions. Factory dyno testing, simulating real-world conditions. Every engine is tested on a dynamometer dyno before being approved. Sensors monitor power output, fuel efficiency, emissions, and heat levels. Engines undergo cold start simulations down to -40°C and high-load endurance tests, 1,000 plus hours. Extreme climate testing, hot and cold environments. Cold weather testing in Arjeplog, Sweden, where engines are exposed to Arctic temperatures. Desert testing in Spain and Arizona, where engines operate under extreme heat and dust conditions. Evaluations focus on turbo performance, oil viscosity behavior, and fuel system efficiency in extreme climates. Real-world road testing, millions of miles before production, prototype trucks fitted with new engines undergo millions of kilometers of testing across Europe, North America, and South America. Tests evaluate fuel economy, emissions, reliability, and driver comfort. Data is collected via telematics systems to analyze long-term durability. Load and stress testing, simulating heavy cargo engines, are tested with full load simulations, mimicking mountain climbs and heavy-haul scenarios. Turbo compounding technology is assessed to maximize efficiency under stress. Emission compliance and sustainability testing, wind tunnels and lab testing ensure compliance with Euro 6, EPA, and future CO2 emission targets. Exhaust aftertreatment SCR, EGR, DPF is fine-tuned for low NOx emissions. Alternative fuel engines HVO, hydrogen, undergo long-term emission performance analysis. 3. Future outlook. Volvo's roadmap to fully sustainable trucking 2025 to 2030. Expansion of hybrid diesel-electric powertrains. 2030-2035. Rollout of hydrogen combustion and fuel cell electric trucks. 2040. Goal of a 100% fossil-free truck lineup. Volvo's SCUVed engine plant and R&D centers are driving these innovations, ensuring their trucks remain powerful, fuel-efficient, and future-proof. Volvo's hybrid versus hydrogen technologies. A comparison as Volvo moves towards a sustainable future in heavy-duty trucking. Their hybrid and hydrogen technologies each offer unique advantages depending on the application. Let's compare these to cutting-edge innovations, focusing on how they impact performance, environmental benefits, and future viability. 1. Volvo's hybrid electric powertrains. How it works. Combines a diesel engine with an electric motor. The electric motor recovers energy during braking, regenerative braking, and stores it in lithium-ion batteries. The diesel engine provides long-range capability, while the electric motor powers the truck in urban environments, reducing fuel consumption and emissions. Key features: energy recovery. The hybrid system recycles energy from braking, improving overall efficiency by up to 30%. Electric-only mode. In cities or congested areas, the truck can run in pure electric mode for short distances, reducing noise and emissions significantly. Performance. Hybrid trucks still rely on diesel for long-haul journeys, providing power and torque for heavy loads. Fuel economy. The diesel engine is optimized for long-range efficiency, while the electric motor enhances fuel savings, particularly in urban stop-and-go driving conditions. Ideal applications. Urban logistics. Ideal for trucks operating in urban environments or regional routes where short-distance driving is common. Last-mile delivery. The hybrid system is perfect for city deliveries, allowing for zero-emission driving when entering low-emission zones. Challenges. Range. While hybrids are efficient, they still rely on diesel engines for long hauls, making them less suitable for truly long-distance operations without access to charging infrastructure. 2. Volvo's hydrogen combustion engines H2ICE. How it works. Hydrogen combustion engines are similar to traditional internal combustion engines, but run on hydrogen as a fuel. Hydrogen is stored in pressurized tanks and injected into the engine, where it combusts, powering the truck. The byproduct of this process is water vapor, making it a zero-emission option in terms of tailpipe output. Key features: zero emissions. The only byproduct of hydrogen combustion is water vapor, making it 100% emissions-free in terms of tailpipe emissions. Fueling speed. Hydrogen trucks can be refueled in minutes compared to the long charging times of electric trucks, making them practical for long-haul trucking. Range. Hydrogen combustion trucks can offer a range of over 1,000 kilometers on a single refuel, rivaling traditional diesel trucks. Performance. Hydrogen engines offer high torque and are designed to handle heavy loads, making them suitable for long-haul and heavy-duty applications. Ideal applications: long-haul trucking, perfect for high-mileage operations, where long refueling ranges and quick refueling times are essential. Heavy-duty applications. The high power output and torque from hydrogen combustion engines are ideal for construction, mining, and long-haul transport. Challenges: infrastructure. Hydrogen refueling stations are still limited in availability and often require a robust infrastructure investment to be viable on a large scale. Hydrogen production. The environmental benefit of hydrogen depends on how it's produced. Green hydrogen produced using renewable energy is preferred, but much of the hydrogen today is still produced using fossil fuels. Key differences: feature hybrid electric powertrains. Hydrogen combustion engine emissions reduced emissions, especially in urban settings. Zero emissions, only water vapor. Fuel type diesel plus electricity. Hydrogen via combustion. Refueling. Charging time: diesel refueling plus electric recharging longer. Quick hydrogen refueling 10 to 15 minutes. Range limited by battery and diesel fuel range. Long range 1,000 kilometers. Best for urban logistics, last mile delivery, regional routes, long-haul trucking, heavy-duty applications. Infrastructure: charging and fueling stations needed for hybrids. Hydrogen refueling stations still in development. Fuel efficiency up to 30% more efficient due to regenerative braking. Highly efficient with high torque output. 3. Upcoming Volvo truck models with hybrid and hydrogen technology. Assured models: Volvo FH electric hybrid, designed for urban and regional use, combining diesel and electric powertrains for efficient, emission-reduced operations. Volvo FM Hybrid offers electrified solutions for the construction and distribution sectors, with a focus on energy recovery and reduced fuel consumption. Hydrogen models coming soon. Volvo FH Hydrogen, expected to roll out in the 2030s, powered by a hydrogen combustion engine, offering a range of up to 1,000 kilometers on a single refill. Volvo FMX Hydrogen, focused on heavy-duty and construction applications, featuring a hydrogen-powered engine for large-scale operations. 4. The road ahead. Which technology will dominate? While both hybrid electric and hydrogen combustion engines are innovative solutions, hydrogen combustion seems more poised for the long-haul and heavy-duty sectors due to its longer range and quick refueling times. However, hybrid electric powertrains offer an immediate solution for urban logistics and regional operations where short-distance driving is the norm. Volvo's push towards sustainability in its trucks will continue with fuel-efficient diesel, hybrid electric, and hydrogen combustion technologies playing critical roles in the transition to a zero-emissions future by 2040.